it's really a three-step process here, right? Separate, integrate, try and solve for the dependent variable. I'll just say that's not possible in this one. So if you got stuck at that step, that's fine. Both of these answers are going to have implicit solutions. So we won't actually be able to find an explicit solution. And so the tricky part is the integrate step. That's the step that I think it's good for us to try and review a little bit. So when we separate this, I'll do that part. We would bring our z's over here and our q over here. And we have a z over here as well. So I think when you separate it, it's going to look like this. And so that z prime is implied that it's dz dq because q is our other variable. And so any questions about that part? And then we want to integrate. So I don't think this one's a little more straightforward. So I'll start there. I've got 1/2 q squared plus c. What happens on the left side? Anyone figure out how to do that one?
You're able to just, sorry?
Oh, sorry. Our group split it apart. So we did z squared over z plus 1 over z, or the integral.
Yep, good.
Yeah.
So you can break up sums in the numerator. So we could just break that up. And now we have a sum of 2 power functions, so we can integrate each of those. Right, when the sum is on the bottom, we obviously need to be a little bit more careful. But here, we can break up that sum. So this becomes the integral of z plus 1 over z dz. And then on the right side, we've got this 1/2 q squared plus c. And so here we've got 1/2 z squared. And here we have the natural log of the absolute value of z. So in some sense, if you were just asked to find a general solution, you would be done at this stage because there's no way that I can solve that for z. But we want to solve this initial value problem. So now I can plug in these initial conditions at any point. I'm going to do something, what might be nice to do to both sides of this equation just to clean it up a little bit.
Multiply everything by 2.
Yeah, so maybe if we don't like these fractions, right, I can do whatever I want as long as I do the same thing to both sides. And I'm just going to say, if I multiply the arbitrary constant c by 2, I just get some arbitrary constant that I'll call d.
Would it be 2 ln of z?
Yeah, thank you. You're right. I did forget my 2 there. That I need there. Thanks. And at this point, we can plug in our initial condition, which is, this is telling me that when q is equal to 2, we should have z is equal to 1. So I'm going to plug 1 in for z. I get 1 squared plus 2 times the natural log of the absolute value of 1 is equal to q squared. Q is now 2. And then we would solve for d. So I get 1. Natural log of 1 is 0. Is equal to 4 plus d. So therefore, d is equal to -3. So my initial value problem would therefore have a solution of z squared 2 times the natural log of absolute value of z, q squared plus, actually, here we go. And then I can plug in -3 for d. So in this case, that's pretty much as good as we can go. I can't really make that look too much prettier.
When we did ours, we didn't multiply by 2. So we ended up having like z squared over 2, and the natural log of absolute value of z equals q squared over 2. So when we did the constant, we ended up with like -3/2.
Yep. And
That's
it's
okay.
equivalent, right? If you took that equation and multiplied both sides by 2, you would get exactly what I have here.
Okay, so is it okay to do that? Like you don't have to worry about simplifying it further
Yeah,
before
that's
you.
fine. Yeah,
Okay.
if you just stopped at this point and said, using that form, I'd get 1/2 z squared plus the natural log of z is equal to q squared over 2 minus 3/2. That's the same exact equation as that one over there. Yeah.
Okay, cool.